today we're going to be talking about parallel lines, some things we can do with parallel lines, and of course we're going to get some new vocabulary. With geometry we have a lot of new vocabulary with what things are named. So I'm going to start by making two lines. And let me just make sure it has arrows on both ends. So we have two lines that are parallel. I'm going to cut them by a third line. So this creates a whole bunch of angles. So I'm going to call this line M and this line N. We'll say M is parallel to N, and it's cut by a third line L. So we have two lines that are parallel, and I have to tell you they're parallel using our geometry symbols. So use the arrows. We made a whole bunch of angles. So let's label them. Let's say angle 1, angle 2, angle 3, angle 4, 5, angle 6, angle 7, and angle 8. Because we make angles by drawing and intersecting lines. So we have a whole bunch of angles now. And our angles are all related to each other. They all can add up to certain things, or maybe they're equal. We have a whole bunch of different ways that they're related. So let's take a look at angle 4. It's definitely a smaller angle, an acute angle. So I'm going to find every other acute angle in there. And if there's other acute angles going on, those angles would be the same. Like this angle across from angle 4, angle 1 is also acute. So angle 1 is congruent to angle 4. We know that because those are vertical angles. We're going to add some relationships. We also know angle 5 is an acute angle. That's also congruent to angle 1 and angle 4. And angle 8 would be our last one. So all 4 of those angles are congruent. Angle 1, 4, 5, and 8, they're all the same angle. And we know angle 1 and angle 4 are vertical angles. But there's some other names that we could use to relate some of the other angles. So like angle 4 and angle 5, they have their own special name. We know vertical angles are angles across from each other, like angle 1 and angle 4. That's a pair of vertical angles. And then in your notes, I want you to find another pair of vertical angles on your own. Check that tomorrow. I'm not going to write it out for you, but find another pair of vertical angles besides angle 1 and 4. There's a lot of options. But some of the other angles have relationships we can talk about as well. I'm just going to get rid of this line really quick. So let's say we're going to talk about angle 4 and angle 5 specifically. They have their own special name. So we look at our two parallel lines, and we usually look to see, are the angles inside the parallel lines, or are they outside the parallel lines? So are 4 and 5 inside or outside the parallel lines? Well, they are inside the parallel lines. So we call that interior in geometry, just like we had remote interior angles on triangles. So 4 and 5 would be interior, 3 and 6 would also be interior angles because they're inside the parallel lines. And then 1, 2, 7, and 8, those all would be exterior angles. But then we look and see, well, how do these angles, 4 and 5, relate to the line that's cutting through? We call L the transversal because it's cutting through the two parallel lines. So they're on the opposite sides of the transversal. Well, again, we don't usually use straightforward. We go and make it a little fancier, a little more mathy. So instead of saying opposite, we say alternate interior. They're on either side, they're on opposite sides of the transversal, but they are inside the parallel lines. So angle 4 and angle 5, we know they're the same, and we know they're alternate interior angles. So again, I want you to name a second set of of alternate interior angles. You don't have to put the question marks, I'm just trying to show you what space I would like you to write the second set of alternate interior angles in. So we could also find angles that are alternate exterior. We want angles outside the parallel lines that are on opposite sides of the transversal. So if I were to look at angle 7, what angle would be on the opposite side of the transversal, but also outside the parallel lines? And they can't be directly next to each other. So 7, 8's on the other side of the transversal, but they're right next to each other. We have to jump all the way to the top, and angle 2 would be the other angle that goes with angle 7 if we're looking at alternate exterior angles. So we have our vertical angles we had already seen before. Now we're adding alternate interior, which are angles inside on opposite sides of the transversal, inside the parallel lines, opposite sides of the transversal. Alternate exterior, again, you could find another pair of alternate exterior angles. We also have 2 more names we can talk about with this picture. We have 2 more types of angles we can talk about. We can talk about corresponding angles and consecutive angles. So consecutive angles are both inside the parallel lines, and this time they are on the same side of the transversal. And instead of equaling each other, they're going to add to 180. If we know angle 4 equals angle 5, and angle 3 equals angle 6, then 5 and 6 together add to 180. Well, that means if 6 is also the same as 3, then 3 and 5 would also add to 180. So we call those consecutive. They're right next to each other on the same side of the transversal. Angle 3 plus angle 5 would equal 180 degrees. Now the ones right next to each other, we could look at that relationship as well. We know what angle 5 and angle 6 add up to be, but that's because we've talked about supplementary angles. We know 5 plus 6 would be 180, or 6 plus 8 would be 180, or 5 plus 7 would be 180, because they're right next to each other on a straight line. And then the last one, I feel like corresponding is almost like you're playing leapfrog. You start at an angle, and then jump over one angle to get to the next one, again on the same side of the transversal. So like angle 7, if we jump over angle 5 and hit angle 3, then those angles would be congruent, and we would call their relationship corresponding. So most of the relationships are congruent. There's a few that add to 180, but they just have their own special names that we need to know for working with angles on parallel lines. So let's look at an example. Say we have these 2 parallel lines, and let's say we know this angle measure here is 152 degrees, and I would like you to find this angle measure here. So first we have to identify what kind of angles are we looking at. Are they vertical angles? Are they corresponding? Are they alternate interior? Are they alternate exterior? Or are they consecutive? So we look at the parallel lines first and we say, well, these angles are outside the parallel lines. That means exterior. And they're on opposite sides of the transversal, so we have an alternate exterior setup. Well, we look back up at alternate exterior. We know alternate exterior angles are congruent. So I know the angle I'm looking for, question mark, is equal to 152 degrees. They were congruent, so it's the exact same angle measure. So let's take that one step further. Let's say we don't want to just find an angle measure. Let's say we want to solve an equation. This time I'm going to make the setup a little trickier. We're not just going to have one line crossing through. So we say these two lines are parallel. Say I have two lines crossing through. Let's say we have 2x plus 10 there, x plus 15 there. So let's say I would like to solve for x. So we have 2x plus 10, we have x plus 15. Both angles are inside the parallel lines. So we have a couple of options. Alternate interior, we're both inside. Consecutive are both inside. And that is it. So we can pick from those two. We have 2x minus 10 inside, x plus 15 inside. Well, we know alternate interior was on opposite sides of the transversal. But our transversal, again, that line that cuts through, 2x plus 10 and 2x minus 10 and x plus 15 are on the same side. So that means we have consecutive angles. So we go look again at, which is on the other page for me, we would look again at our definitions, alternate interior, alternate exterior. We said we decided they're consecutive, and we know consecutive angles add up to be 180 degrees. That was the wrong button. I meant to hit this one. So we know these two angles added together equal 180. So we set up our equation. We say the first angle, 2x minus 10, plus our second angle, x plus 15, equals 180. We've been practicing a lot of these equation setups and solving, and most of the time what we have to do first is combine like terms. So we look for our like terms. We have 2x and x. Combining those together, we get 3x. We also have negative 10 and 15. Negative 10 plus 15 is 5. Then the other side we haven't used yet, equals 180. So now I have to finish solving my equation. We use opposite operations now. Opposite of adding 5 is minusing 5. We get 3x equals 175. Then we divide by 3. So we would get x equals 58.3. I'm going to double check that on my calculator. Good, that was correct. Okay, so again, that only gives us x. It doesn't give us the angle measure. If it says solve for x, we're good. But what if I said find angle, and now I need some labels. Let's say we've labeled this A, this point's B, this point's C, this point's D. What if I say find the measure of angle ABC? Well, I would take that answer I just got and plug it into my expression for ABC. So ABC was the angle starting at A, going through B, and hitting C. So the angle that contains is 2x minus 10. So we're using the 2x minus 10, and everywhere we see x, we'd replace it with 58.3. And then we'd solve. 2 times 58.3 minus 10 is 106.6. So since I made this problem up off the top of my head, then I didn't place that in the correct spot. Notice that angle is acute, and we got a obtuse answer. And that's because I did not check the work first, which I probably should have. But if we moved it and put 2x minus 10 down in the x plus 15 spot and the x plus 15 in the 2x minus 10 spot, it matched the picture a little bit better. But it does bring the point, never trust the picture in geometry. When they give you a picture on a test, they may make it look one way, but you do the work and it's actually something a little bit different, so you do have to be careful not to trust the picture. So one more question I could ask about a problem like this. What if I knew that over here we had, this was 27 degrees. We now know ABC, and I said find, actually I shouldn't use x since we've been using x's. Let's call it y instead. And I said find y. Well, I'd have to take the answer I just got and use the 27. And if we look at those three angles, they're all on a straight line. We know that 27, y, and 2x minus 10, they're all in a straight line. So they should all add up to 180. So we can then use that information to find y. We can say 27 plus y plus 106.6, all of those together should equal 180, and solve that equation. So I can take this picture and ask a lot of different questions. If I just said solve x, we would have been done at the very beginning. If I said find the measure of one specific angle, we can find that by plugging it back in. But then sometimes we have to use the picture itself and say, well, find one of the angles on the picture itself by knowing that the straight line is 180, or I could have used that a triangle adds to 180. Again, we would just combine like terms. We would get 133.6, I believe. Again, I'm going to plug it into my calculator to be safe. 133.6. Then we just use opposites and subtract 133.6 from both sides. 180 minus 133.6 is 46.4. So, kind of a recap, we learned all the different angle relationships when we have two parallel lines. Alternate interior, alternate exterior, consecutive, corresponding. We still have vertical angles, we still have supplementary. We didn't write supplementary down. We should be able to recognize that because we've been using it before. We talked about the different ways to find angle measures when you're given a picture with information about the angles themselves. Also tomorrow we will be having a quiz, so be prepared to take a quiz tomorrow.